Hey guys, Ivan Lima here. Today we're going to be talking about indexes in 4 steps. Okay, we're going to try to understand the base of indexes. And I guarantee you that if you're a developer and you follow this, you're going to be 90% ahead of any other developer. Be a database developer who is starting, or be an app developer who usually don't really care much about databases. And knowing that database is like one of the main bottlenecks in an application, this will be helpful, very helpful for you. Okay. For that, I'm gonna have a script here. This is the script that I'm gonna have. I'm gonna have the link for you to download this. Okay, so you don't have to write all this, and then we're gonna follow along as we go here. For that, I had a schema called play that I created. You go ahead and create whatever schema you want. I will also be using set statistic IO1 and statistic time on. We're going to talk a little bit about this, okay, how this plays around in what we need. But I also have here a file that I will be distributing. We're going to be populating this as we go through this discussion right now. And then I'm going to have this ready also on GitHub for you to download in case you want to see. Okay, the numbers that if you run this script, you're going to get some numbers that might be a little bit different of what I'm going to get, but that's okay because the concept is the same. Okay, so another thing that I want to talk about is that I will be using statisticsparser.com to be able to read, to see the logical reads of what's happening in my query. And also we're gonna have the execution plan to show up, okay, because we're gonna be evaluating a lot of the execution plan. So to start with, um, we're gonna have 4 different tables, okay? One table is the table 1, and this, like I said, it's already there, okay? For me, I'm not gonna run this again because I don't wanna wait here for another 5 minutes to have this running. But I'm gonna tell you what we have here. We have table 1, and we're gonna insert 200,000 records. See that the data types here are all varchar except for the datetime, of course. And I'm using unique identifier and converting them to varchar for all these columns. It's easier to show what I want to show using varchar, okay? The second table, and one more thing is that we don't have any indexes here, right? The second table, however, we have the same thing, the exact same structure, but this time we have a primary key. So we create a primary key on the first column, that's it, and then we inserting 200,000 records in there as well. On the third, again, is the same thing with one more exception. Now we have a clustered index in column 3, right? So this column here is going to have a clustered index, okay, but it's also going to have a primary key. Then I've inserted the 200,000 records, and the last one is going to be table 4, which will have also a primary index, and we're going to insert. Initially, I just want to insert 3. We're going to later on see something about this one here on line 77, but I only want to initially insert 3 indexes, okay? And then 200,000. So each one of them is going to have 200,000, okay? The way I want to start is by actually, since I already have this all in, okay, what I want to do is I want to select, okay? So I'm going to select all 4 tables, and we're going to take a look in the execution plan as well as in the message for the statistics, okay? So when I run that, let me bring this up. Okay, for the first 4, 1, 2, 3, and 4, okay? It's completed, right? We see that this one here has a little bit more than 200,000 records. It's because I was playing with it before. This one here also has like 2 records more than 200,000. Let me see this one. This one has also two records more, and this one. So they all have the same amount of records, okay? If we check at the message, right? And the reason I'm getting this message here, so for those that don't know, it's because of this here, okay? If you don't have this on, this is not gonna show, okay? So make sure you run this, right? But the reason I have this, the way I have this in here and how I'm gonna do is I'm gonna actually copy so it's easier for me to read, and I'm gonna come to this website that I said, statisticsparser.com, okay? When I paste that in there and I parse, I'm gonna see few numbers here. This is in the order that I ran. I ran the table 1 first, as you can see here. That's table 1, that's table 2, that's table 3, and that's table 4. Couple of things here to think about is the time, okay, and that's why I have time on in there. So he's kind of like telling me the time, how long it took to run it, okay. Um, but I don't really want to focus too much on the time. The reason being that, as we know, what is running the background of the server, it's not always the exact same thing. We don't never know it's gonna influence time of a running query. So most of the time, this, even though we have that in here, this might be useless unless we have a really drastic changing number, right? For this here, for example, I see a changing. This is 948 for the total elapsed. This one is like a second and something. This one is 950, almost a second, and this also was almost a second, right? And that's actually not even this is just elapsed time, right? It's not even the CPU time. Okay, the CPU time, I would say that it's even more important. And this one we have, this one is 0, this one is 32, very close, right? This one here is 0 and 0. So we can see that, I mean, we can actually see that as far as CPU time, all these three here seems to be okay. But again, like I said, I don't care about CPU time right now. What I really care for now is the logical reads. And those are the ones that I'm going to take notes, okay? Logical reads is pretty much how many pages SQL Server or the engine had to read to execute those queries, okay? So I'm gonna open this Excel spreadsheet here, and I have already things laid out here, and we saw that we had a select all right? That was the thing that we had here. We run these 4 queries here. Select start from 1, from 2, from 3, and from 4, right? So I'm gonna just copy this and see the pages so that I can later on take a look at and see if that's gonna make any difference for as I move along with the select. But the first one, it read 3449 pages. The second one, which is a clustered index, which has a primary key, is a 4857. The next one was 4863, 4863, and the last one was 4742, right? So I can see that this one here took less resources, and these other ones, they kind of like took about the same, right? This one has a little less than this other two, but it's pretty close, right? So, and I can probably see that difference right here in the execution plan as well. So if I go here to the execution plan, it tells me relative to the batch, meaning all the four queries that I ran, how much resource and percentage did this one take, and this one take, and this one take, and so forth, right? So we said that the first one took 20%. The other ones took about the same, except for this one that took 26, but it's pretty much the same. And that kind of matches with this, right? So this was less, and this similar, with the exception that this one was a little bit less, right? So what does that tell us? That tells us that a table without an index, which is this one, right? It's called a heap table. Okay, so remember that name. That's a heap table, which means that there's no clustered index, there's no index at all. Okay, and if you also look into the store procedure, oh, I'm sorry, in the store procedure, not the execution plan, you're gonna see this sign, and it's gonna say there, table scan. That means that you checked the whole table, okay? But this is a table, a heap table. It doesn't have a clustered index, right? Different than this one here, the second one. Let's check the second one. The second one is saying, okay, it's also doing a scan, as you can see here, or you can also see here in the top, scanning a clustered index entirely or only a range. But that means that it's doing a whole scan, but this is doing a scanning a clustered index, okay? So a table inside of the database, you're gonna have either a table, a heap table, or a clustered or non-clustered table. Okay, which in this case here, this is a clustered index table. We put the primary key in there. It's even telling you, hey, who is the primary key? And it says right there, PK first column, right here, right? You can also see here, if you check here on the yellow thing, you're gonna see that it's the clustered index name is the PK first column. So that would be the main difference between those two. And that also tells me that it looks like for select star from the whole table, this one performs better. The reason being, it's probably because it doesn't have a little over, like the clustered index gives us a little overhead for select star, right? Because it takes, it takes more resources. So we might now think, okay, so then I don't want indexes. No, that's not the case, because how often do we do a select star, right? We don't do select star very often, or we shouldn't. right? In fact, the star itself, it's probably not a good thing to do, select star, and we'll see that later on why, okay? But if you are like 100% sure that your select is going to be a select star from a table, then yeah, sure, table scan. And that's what kind of happen when we're doing sort procedures. Sometimes we create temp tables, and we don't care about creating an index on those because we're just going to select everything, okay? So that's what it is. Now for the other ones, let's check out the other ones. Let's see how they look like. So for this other one, we have a clustered index, right? And we also have an unclustered index on the third column. But in this case here, it chose to pick up the clustered index to do it, okay? See that the resources are the same, right? And I'm going to show you how we're going to actually compare both to see if they're actually the same in a bit. But like the resources taken are the same, and it's picking up based on the clustered index, which is the PK first column 1, right? And then we have the last one, which is taken last. And this one, as you can see there, this is not actually coming from the clustered index. It's coming from the non-clustered index. So it looks like the non-clustered index might be even faster sometimes than when we're running through a clustered index. So this one has few non-clustered indexes, and it took less resources. Well, the engine will figure that out. That's not something that we have to figure it out. The engine will usually figure that out, right? But let me also compare select 2 and 3. So I did that. And if I do the execution plan, I see that both has 50%, 2 and 3, right? Meaning, yeah, I mean, they're doing pretty much the same thing, right? But if you compare 3 and 4, we'll see that the execution plan for one is a little bit over the other one, right? Again, this one is picking up the non-cluster. This one is picking the clustered index, even though this one has an unclustered index. And we're also going to try to discuss a little bit why this one is picking the non-cluster, okay, later on. So that's first, okay? That's the first 1, 2, 3, and 4 steps. Now we see how a select star works for tables with a heap table, with a clustered index, with non-clustered index, and so forth. Now let's see how it's gonna be when we do a, well, actually I wanna show one more thing here. Let's come here to the results. Let me run this again, because I think this is important for us to understand. And that's the main reason why I put the timestamp in there. I want you to see this, okay? Let's open this up a little bit more because I want to focus quite a bit on this. On the first column, since this is a heap table, every insert that comes, it will come to the next row, okay? And how can I actually tell you that that's happening? If you see in the timestamp, you see that this is going in the, it's ascending order, right? We don't have, it's not mixed up. It's in ascending order. You can go check in there, and the last record will be the last one, really. Like that was the last one that was inserted, and this was the time that it was inserted, okay? If you check this one though, this one is based on the clustered index, right? Now we're gonna see this one was 35, 39, which was before in this, that's fine. But this one here, look, this one here was actually, this one was inserted before all these two, okay? And why is that? The reason is because a clustered index will insert, but you will have to order whoever is the clustered column, right? So in this case, even though this guy, he was inserted first, this guy he's showing first because in the order, right? This in the string order, this here comes before in this. So this guy he came first, but this one is showing first. Okay, this is the first guy. That's why we have the timestamp here, so we can actually see that that sort is happening. Okay, so if I go to the last one, this last one, I mean, it was after this one, was also after this one, but it's probably like it was not after this one, as you can see, okay? And if we look here in field record, you see that they're not in order of time. They're in order of the first column because it's the clustered column, okay? So the clustered column, every time it does an insert, it will order the clustered column, okay? The same for this one, because this one is also, there is a clustered index. So if you, I mean, I'm not gonna point this out here, but you're gonna, once you run, you're gonna see that the timestamp here, it's not in order. The only one that's gonna be in order is gonna be the first one because it's a heap table, okay? Now, once, if we have to do an order, and let's do an order by the, well, this is actually first column. First column, okay. So let's do an order for the first column, right? I'm gonna run all of this, and then we're gonna see what's gonna happen. I will pick up the message. Is it done? Yeah, it's done. So now I'm gonna come here, and I will parse it, and we'll see what happened here, okay? All right, we see that in an order by, we have again the same number that we had previously, 3449. We're also gonna have the 4857. We're gonna have the 4863. And we're gonna have the, what was it? Well, am I missing something here? 3, where's number? Well, 1, 2, 3, didn't I run 4? Okay, let me run that again. I maybe I didn't, let me run it again and see if that's gonna come now. Order by first column. Maybe it wasn't ready when I copy. All right, let me copy again. And let me go back there. All right, so I have 1, 2, 3, and 4 this time, right? The numbers there are still the same. 4863, and then the last one of 4842. 4842. And then we might think, okay, this one is probably still doing better, right? Because now we're doing, the logical reads are still smaller for this one, and the other ones are bigger, and they're actually the same as the first one. But let's see what the execution plane is going to tell us. Well, now the execution plane is telling me that this one is actually taking a lot longer, or taking more resources, 31% against 30, 23, 23, and 23, right? And why is that? If we see the path of this execution plan, we'll see that there's a sort involved. Okay, there's a sort here. And then it comes to parallelism to get it all together, and then we get the results, right? But these ones, on the other hand, they do not have a sort. And why don't they have a sort? Well, because when we do the clustered index, it automatically sorts, and the engine knows that. It knows there's a clustered index, and if I am ordering by that specific column with the clustered index, it will know that's already sorted. So it does not have to sort. So even though you're reading a bunch of pages, this one takes less resources because I don't have to do anything else. Right? I just have to pick up the data that's there. So now we see why indexes can help, because in an order, it will help, right? And let me compare these three here. I want to see if they are anyhow different when it comes to the execution plan. All right, so it looks like that they're all the same. 33%, 33%, 33%. Why? Because they're picking up on the cluster index, right? And they have the same amount of rows, so it's the same, right? The difference is just on the number of the pages, like we saw here. And that's because the way it is stored, it might have, some different pages, but it's very similar, right? There's like how many different pages here? 57 to 63, you'll be about 42, about 20 pages, right? So that's nothing for the engine. Okay, so now we're gonna do a select with a filter on the clustered index. So this is the first column. They all have, except for this one. This one doesn't have a clustered index, but all the other ones do, right? And then we're gonna see what's gonna happen. Execute it. Let me come to the messages. Let me pick this up, and let me come here. Parse it. All right. Again, logical reads 3449. I was already expecting that because that's a heap table, and a heap table we always will have to do a scan. Doesn't matter if you put a filter there or not. So 3449. The next one, which has a clustered index on the column that I'm filtering on, you only had to do 3 logical reads. What about the other ones? The other one also have the other ones only have also have the clustered index, right? So I'm expecting also 3 and 3. Let's see how different are they here when it comes to the execution plan. So I know, look, it's so different. If you have a filter, it's so different that even though these 3 guys here, they're taking some resources, are so minimal compared to this one, right? This one is saying that's taking 100%, right? So it's probably 99.9999 whatever percent, and then there's like so little here. So we see that the filter on the clustered index will make a huge difference, right? I can even do this. Let me see on these 3, what's gonna happen here as far as execution plan. 33%, 33%, 33%. That means that they are pretty much doing the same way, right? They're working the same way, right? Just one thing. Don't worry about this value here, okay? I actually put a value here that's not gonna be part of my column. And I want that way because I want my database to look for the whole thing, for the whole table, right? If it has to. But now we saw how index can help on a filter. If we have a, so primary keys, and the reason why they have primary keys as the clustered index usually is because that's where you're going to be doing the joins mostly, right? So that's going to help tremendously. Okay. All right. We're going to go now to a column that does not have an index. If we take a look here, and again, let's just take another look. So the first table has no indexes. The second table has a primary key index here in the first column, but there's no non-clustered index. The third table has a column, an index on the third column, but not on the second. And the fourth table also has an index on the third, but not on the second. Okay, we're gonna talk about this later. All right, so on the second column, let's run that and let's see what's gonna happen. And you see that it's not returning anything because that value is just not there. Okay, and I don't care about that. That's fine. All right, so let me pick up this information. Let me come to the parser. And again, we're going to see the same number there, 3449. Okay, so with no index, it's going to be 3449 in the column. Then 4857. Then 4863. And last one is the 3091. We see that this one actually read less, right, than the other ones, right? And it might have to do with this here. I'll show you. It might have to do with one of these indexes here, right? It's picking up from, let me see, what is the index that's picking up? We're actually going to check the execution plan, but the index that's being used is the IX4 third column 2 3. So it's actually using, oh, what is that again? IX column third column 2 3 include. Is that for the fourth one? Yeah, I'm not sure what I'm not actually sure what index is this one. If I don't have it, oh, it's, well, wait on a second. Let me drop this. This was already there because it's picking up this column here. We're gonna do this again to see because I actually don't want this there right now. Let me drop it for a second. Drop index this. On 4. Oh, I already had that in there, but okay. Let me drop it. Okay, fine. I don't have that anymore. Let me remove this. I don't want this in my query. And I'm going to do this. I'm going to run this again, okay? Because I want to make sure I get the right numbers there. And it might actually be the same, but I don't know. Let's see. All right, parse. This is the same number, there's the same number, there's the same number, and this one actually came to, let's see if it's the same than before. So it's still a little less, 4420. So let's put here 4420. And let's try to understand why. The reason is because here on that index, it's actually picking up from the 4 third column 1 include. So it's picking up from this. And since this second column is in there, it looks like it's trying to use some of that, whatever logic is in there behind it, to read less, okay? But it's still not perfect. And if we see also the execution plan, we'll see that this one here now is taking less. Why? Because it's doing a table scan, there's no overhead. This one here is doing about the same as this one, 27%, 27%, right? Why? Because it's doing a full clustered index scan, and a clustered index scan, we know that there's a little bit of overhead. And this one is doing a little bit less, 25%, most likely because of the second column here, may include, okay? So I can also do something like this to compare a little bit more. Like if I do, for example, this two here will probably be about the same. Actually, the execution plan is 50% and 50%. And this here, it's going to be a little bit different. 52 and 48. So we can see that it doesn't really make much difference, right? And even does a key lookup here. So which is I would actually expect this should be a little bit more because of the key lookup. But okay, it came a little bit less. but they're all about the same, right? So we're now going to go to the third column. The third column is the one that we have indexes for column 3 and 4. One that has no indexes, 2 has a primary key, 3 has one non-clustered index, and 4 has 3 indexes right now, right? I'm also doing select star, and we're going to probably talk a little bit about select stars here now. But let me do a select. All right, did that for all of them. Let me copy this. Let me paste on my parser, and let's take a look at it. All right, so non-clustered index. All right, so the first one, 3449. Already expected that number. Second one, 4857. I did expect that number. Why? Because it has no, there's no non-clustered index, and I'm filtering based on a column that has no indexes, right? The next one, though, we have a 3. Come on, okay. Next two, I have a 3 for the table 3 and 4 and 3 for table 4, right? So now we see there's some performance on the resources here, better performance, right? So if we go to the execution plan, we see that this one's 42%, which is better than the 58% with the cluster index. But this one, I'm pretty much 0, right? This one, I'm pretty much 0, right? So, and if I compare those two, let's compare those two. Because if, we'll see which one's going to be. This one here will probably take more resources than one of the KiloCup. And we're going to talk a little bit about that. But if I go there, you see this one is now taking 67% out of 33. So it's kind of a pretty good difference, right? And the only reason this is happening is because we have a select star here. And what the select star does in that case, select star is just trying to, like when we do a clustered index, when we create that, that will pretty much have all the other columns in the cluster table, right? But a non-clustered will only have the columns that you put in the non-clustered. So in this case here, let's take a quick look here. On the third column, I have an index on the third, sorry, on table 3, I have an index on the third column, which is this one, right? But I'm doing a select star, which is picking up this, this, and this. So once I do this, it's going to have to go back to the clustered index and pick up the information for the other ones, for the second and the timestamp. The first column, it's already, we don't see it, but when you create a non-clustered index, this one here, there's a reference to that one. Like the engine knows what will be the clustered index if it has a clustered index, and based on that, you know that there'll be references or pointers that will where we'd be able to go to the clustered index and then pick up any other column before, right? But in this case here, it's just like we go to the supermarket and buy orange, go back home, and then we go back there and get milk, right? When we could both take both together, we only took one. We had to travel 2 times, right? So that's what's happening. On this one, on the other hand, because I had an include on the second column and on the timestamp, it's probably picking up, well, almost sure, I'm pretty sure that's going to be picking up this index instead of any of the other ones. And let's try to prove that. Let's see what is the index that's picking up. As you can see, there is the third column with include. So it's the first index. Why? Because it knows that, hey, hold on. You're creating an index on the third column, but there's an include for second column and timestamp. So now I don't have to go back and get that information again using the clustered index. Okay, so this is what's making this run a little bit faster. Okay, you're taking less resources. And if you can see, it's like, this one is taking 2/3 of everything, right? Against 1/3, right? So that's something we keep in mind. We're going to talk a little bit more about that in a bit, okay? And I'll in another query. Okay, but just remember, this is what we call a covering index. It means that we're going to include things in the index so that we don't have to travel more than one time. And you can see here how big of a difference that can make, right? Even though in the page reads, it was about the same. Okay, now let's go to the next one. So there's the third one, right? Now we're gonna do I'm gonna show you here the difference if I don't do a select star, okay? And remember that table number 3 doesn't have an index. Oh, I'm sorry. It doesn't include timestamp or second column. It only includes it only has a third column, right? So let's do that. Let me pick up the message. Let me check this out here. And we're going to see 3449 as expected. So let's put there with include 3449. Then we have 4857. Then we have 3. And the next one, I'm almost sure it's going to be 3. Let's confirm that 3 right there, right? But let's see how that behaves here in the execution plan. And we see that this one, we see this key lookup. So that probably tells me that this is probably, even though it says 0 and 0 here, it's because this shoe is taking so much resources, right? So if I focus on this shoe only, we're going to see the same thing, right? If I do this, now the percentage that we're going to change. 67 and 33 is the same thing. It's the same concept that I just said about the select star, right? So when we're doing a select, we want to make sure that we select the with the columns that we need. That's when they say select star is bad. This is one of the main causes why select star is bad, because if we don't need it, then why we bring in more columns that's not needed, right? And a select star is usually only if you're gonna do a join on the clustered index, because remember the clustered index brings everything, okay? Just the non-clustered that doesn't, okay? All right, we're gonna go to the next one. Now we're gonna use a function. What's gonna happen if we use a function in the non-clustered index? And that also applies to the clustered index, okay? But I'm just gonna show here on the non-clustered index. All right, I run it. Let's go to the messages. Let me check that out. And here we have 3449, as we expected, 4857. So let's put here with the function 3449, 4857, 4863, 4863, and the last one 4742. He read all these pages. But why is that, right? Let's see in the execution plan, see what's going on there. 20%, so it's just exactly the same thing that we had when you run the select star from each table, right? And we can see here, it's all saying the keyword here is scan, 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 and scan. So it's doing a full scan on the table, on the heap table, or on the indexes. Okay, so now we see that a function will kill your index. And we see that over and over, people putting functions on the non-clustered or on the clustered index in a filter, and they don't understand why it's taking so long, right? And that's the reason why we cannot put a function. There are other ways around. We may talk about that in a different video, how to overcome that. But if you need a function, you have to make sure that you don't do that on the non-clustered or clustered index, okay? Otherwise, you're gonna lose the benefits of an index for select, okay? All right, let's also do a like. In this case here, I'm doing a like in between the wild cards, right? The percentages, right? So if I do that, and I have, yeah, we're gonna talk about all of this here. So let's see what's gonna happen. And this one, as you can see, it's taking a little longer to complete. Let me copy that. Let me do it. Let me parse it. All right, so look, we have full scan for all of them. This one, this one, this one, and this one. I'm just gonna copy that in there, and we're gonna talk a little bit about it. So it's gonna be 3449, 4857, 4863, and 4742. Okay, all right. Let's see here, as you expect, it's happening the same as it happened in the previous example we saw, and also in the first one we had a select star from the tables, because it's doing a full scan, and I have a like, and what it's killing this query here is this initial wildcard here, this percentage here. When we put percentage before a character, that will kill your index. And why is that? Well, the reason is because, remember, an index will order things, right? If you put this in here, it doesn't know what should be the first characters to be used. So it's just gonna have to do a full scan again, right? So a like can be bad if we have this here in the beginning, okay? And we have another example here with only that in the beginning, okay? And we'll see what's gonna happen again. Here we have the message. Let's go to the parser. Oops, go to the parser, and here it is. And we have the exact same numbers. Okay, so let me put that in there with the like in the beginning. So it's going to be 3449, 4857, 4863, and 4742. All right. So now and then let's see the execution plan again. 20%, 27, 27, 26. That's what I expected, right? But now let's see what's gonna happen um with a like when the percentage is before. And we might have some weird results here for something, and we're gonna talk maybe a little bit about that because we kind of like I said that I mean it goes by the order, right? And in this case here, he knows that the first character is going to be a 7, so it's going to just filter based on the 7th one and then everything else that comes after. But we might have some unexpected results. And I'm saying that I think I know what's going to happen here on mine because I already ran this. If you run on yours, you might actually have some different results. Okay. Let's see here. Let's check this out. And we're going to talk about this. Let me go to the parser. And over here, I have 3449, 4857. So we have 3449. Then we have 4857, number 2, 4857. And then we have on the third one, 4863, 4863. And then we have on the fourth one, 300. What does that mean? All right, let's go to the execution plan. So this one is saying it's taking 26%, which is better than this second one because this one is actually querying, is doing an index scan on the clustered index, but I'm not using the primary key, so that's why this one is better than this one. But I'm a little bit like trying to understand why this one, because this one, we actually have a index on the third column, right? We have an index on the third column. How come it didn't use it? Because if I see here, I see that it did a scan, right? Clustered index scan, even though I had like a index in the third column. This one, on the other hand, pick up pretty much. It did right. It said, okay, yeah, I'm just gonna pick it up, and I'm gonna do a seek, right? And I'll tell you why. Tell why this probably happened, and the reason behind. I made another video a while back on the architecture of SQL Server. You may find it there. I might put a link in here once we're done. But and over there, one of the things that we talked about was the optimal execution plan that SQL Server tried to find, okay? But SQL Server is not in the business of looking for optimal plans all day. Like it can do all types of calculations to find the optimal plan when you run the query the first time. But eventually it has to say, you know, I have to make a decision. And he makes a decision and goes with it, right? So um, because this guy here is selecting um, the second in a timestamp, remember the timestamp is not part of the include. SQL Server thought, okay, it's probably better for me to do a query in the whole table than to do a query on the seek because I'm gonna have to go back there and pick up this information, right? So that was the optimal plan that you could get, right? And I think this is probably bad, even though we like saying, okay, look, but I have a like here. Why is this not working? You know, so it's probably because you don't have this, and that's the reason. Well, no, that's actually not the reason. I think let me actually. We're gonna go back to the creation of next query later on. Next index later on, but like here is why I put now we're making um, uh, some other queries here where we're going to see how this behaves. Okay, so now we know that this one here, even though I was expecting to have an index seek here, it's not happening. But let's see the other queries. Okay, so here again, it's index scan. This one did a seek, which was, look, 94% against 6%, right? And you also saw this in here, right? The page reads, this one was 10 times, 12 times, I don't know, 15 times more than this one, right? So, but now let's see what happens if I do um, a third column and a second column. I'm actually trying to remember why I did the second column here because this one is also not an include. But let me see here. Let's run it and let's actually see. Let's see what's gonna happen here. Hold on. I just don't remember why I put all of this here, but we're gonna check it and we're gonna find out. 49, 49, and this 3%. So it's still showing. It's still showing the that's doing the index scan, and it's because I don't have the second column in the include, But I'm gonna show you this. Let me show you actually this. Let me actually remove these two columns from here. Let's just say that I wanna just for whatever reason pick up the third column, right? And I know the third column is part of the index, right? So if I run this, let's see if that's still gonna do what type of plan is gonna do. See, now they both doing seek. Why? Because now SQL Server knows that it doesn't have to go there and pick up another information, right? But for this one here, no matter what column I put here, second column, it will always gonna do a seek, right? Because it just, well, I lied, I guess. No, sorry, because I did on the wrong one, right? This should be on the, well, I erase everything I said before. Okay, let me just go back here because to what we was before. This is the third table. The third table doesn't have includes. I thought this was the fourth table, and it's not, right? I want to actually pick up this one and compare with this one because I want to compare the fourth column, right? So we saw that this one here, the second one, since it's the fourth table, which has the include in the second column, will do a seek, and this one we saw that's going to do a scan, right? And again, play with that later, so you're going to see. But this one is a seek, this one is a scan. This one takes 94% of resources against 6%, right? If I do, for example, third column here, third column, and I do, and let me remove this. Let me remove this, and I do those two. Now it's probably going to do the exact same type of resources, 50 and 50, because they're both index seek, because the third column is part of the index, right? But this one here, I can put whatever I want. Actually, there's something wrong here. I didn't put the comma there, but let's see what's going to happen. 50 and 50, right? It's all there. That's good. If I put the timestamp here, and I put the timestamp here, now we're going to see the difference because one is a cover index, the other one is not. Index scan, index seek, right? And going back here, just take another look. It's picking up this one. The first index is picking for the fourth column, it's picking up this index, and the third column is just picking up this one, right? So even with a like in the or alike, or even maybe sometimes even an equal, it might not work exactly the way we want because this is not a cover index, right? And that's why you might see something different in yours. When you run yours, it might come a seek, but what I'm trying to say is that not all the time that's going to happen, okay? All right. So let's go now. So we're done with selects. Now we see how selects can get benefited by indexes, how a heap table works, how clustered index takes more resources if it's just a select star from everything, right? And on clustered indexes as well. But that's not usually the case, okay? But now let's go to inserts, because people say, well, inserts will be bad, right? So let's make some inserts here. So I'm making insert on table 1, 2, 3, and 4. Let me go there. Let me take the message. You're gonna check the message first, see what happens. And here when we insert, look at that. We have, this reads one page, probably just the page that it has to insert, right? This other one has to do 3, the second one with a clustered index, and that's probably the overhead that we're talking about. This next one do 6, and the other one does 12. What the heck is going on here? Okay, so let's take a look in the execution plan. When we do insert, this one takes 13%. The second one took 13%, okay, so which was about the same, right? And we're gonna run those two together and see what happens later on. This one took 25%, the third one, and the fourth one took 50%. And that's because of the maintenance of indexes that it has to do, okay? So let's run the first two first, and let's talk about them and see if we're gonna see much difference when we do an insert here. All right, did that insert 50% and 50%. Then you say, well, but this one on here on my Excel, at least as far as page reads, it had to read 3 pages, right? Well, this is the cost of maintenance of the clustered index. But remember, a table in the database is going to be either a heap table or a cluster table or non-cluster table, right? In this case here is just a cluster table, right? But what about these other two guys here? Because they have a clustered index and they also have non-clustered index. So that tells me that something happened. So if I run this, let me see the execution plan. The first one is taking 33%, the second one is taking 67%. Well, what is so different about them? The difference is that this one has a clustered and a non-clustered, so there are 2 different indexes, This one has 3 different indexes. Here it is. Or 4, can't remember. Okay, there's 4. There's like the primary key, then there is non-clustered for with an include. Another one that is redundant. I just made it so we could kind of like see how things work here. But you know, this one is redundant, but I just created it so we see it. And another one, and we're gonna do this one here in a bit. Okay, so this one has 4 different index to maintain. That's why it takes so much more resources than this one. Okay, well, is 4 indexes bad? No, usually not for a table. But you will find places where you have like 30 indexes there. And that's killing performance for inserts. Okay. Oh, but I need the index for the select. Well, maybe. Okay. You just have to, maybe you could substitute an index for a covering index, right? You have to have in mind what select it's running. Okay. If you know the select that's running, then you'll be all right. Okay. One thing also that I kind of want to show, and I forgot, it was when I did the select. Let me see which select here. Let me go for this one here really quick. Just want to show one thing here, the execution plan. No, not this. Let me do this one. Is this one gonna work? Maybe. Okay, yeah. As developers, sometimes we see this, right? And we say, oh, this is gonna fix all my problems. I'm just gonna create this index, misindex details, I'm gonna create it, and it's gonna fix it. This warning or this the engine is trying to help me say, hey, I'm gonna make it better if you do this. But that could be a mistake, okay? When we just come here and do a misindex details without really knowing what you're trying to get, and that's where we get like to 30 indexes, because people just come here and boom, misindex details. That's a problem. Don't do that. Understand why you need an index, okay? And because we want to avoid, a lot indexes in the table. We have to avoid that, okay? And we saw that in the insert. But what about update? Let's see what's gonna happen in the update. I have the update. I did that. Let me see the message. Let me go to my friend. Let me parse. Well, by now you probably see that a heap table will always read all the record. In that case, he has this many pages. So 3, 4, 4, 9. The second one is gonna be, this one has a, well, let's see, what is the query that we're running there? Again, we're running a query that does an update based on the filter, which is the first column. The first column here, it doesn't have an index, but the other one has the primary key, right? So it has the clustered index. So that's why we see that you only had 3 reads. 3, the next one, 3, and the next one, 3. Well, so we see that this update was great by using the index, right? So can indexes help update? Yes. When people say, "Oh, index is gonna make updates worse," it could, and we're gonna see that in a bit. But here it was 97% against 0, and it got 1 and 1%, right? And why this one probably took less than this one's? Well, let's just run this here and see. Now I want to compare them all. So for this one here, we have 36 against 64. Guess what? This one here has 1 non-clustered index more. So he has to maintain that as well. You have to make sure he updates this as well. It's not updating only the clustered index. He also has to update the non-clustered index, right? And then we have, let's see a comparison, this one with this one. Oh, look at this. This one, the fourth one that has 4 different indexes, it's taking more resources than the first one. So now what we learned here, wait, the update helps on an index, but also the more indexes I have, the worse it gets, right? Maybe not compared to the main, to the what's the name, the heap table, right? The heap table here, it's horrible, 97% against 0 and 1 and 1%. But it still makes a huge difference. It can start making a huge difference when we starting to compare with other tables with indexes. And you see, like, one is 17%, 29%, 54%. This one here has more indexes, right? Let's do an index. Let's do an update based on the column that has indexes, right? Like this one doesn't have an index on the third column. This one doesn't have an index on the third column, but the next 2 does, right? So if I do that, see how that's gonna work. Execute. Get the message. Let's play with it. parse. What do we have? 3449. Well, we already memorized that number. Let me close this a little bit here. So 3449, 4857, and then we have 3 and 3. So the last two ones, they're great. Why? Because they have an index on the column that we use in the filter on, right? So, but let's see the execution plan. 42%, pretty bad. 57%, pretty bad. 0 and 0, and then you say, oh, these are the same. Well, I don't know if they are. Let's run only those two and see what happens. 29% against 71%. Why? This one has 4 indexes, okay? All right, let's go to the next one. The next one now, what we're doing here, it was just a, what's the difference here? Actually, trying to remember what I did this next one. Oh, I'm just doing a set on the third column. I think it has to do with this one is the second column, right? This one is the third column. This one, the second column is present in the index here because it's in the include, right? But we still saw that this one here took much longer, right? Like, or it took more resources. So we're just trying to see if the include will make any changes or it will make any difference on the on the uh, on the update. And if I run this, I'm actually expecting the same numbers. Let me just see here. And let me see if I have that in the Excel, because if I don't, okay, I don't even have that in the Excel, so I'm not going to even play that in there. We're just going to check in the execution plan because it's the same, right? 42, 57, 1%, 1%. But what if I run only those two? I'm expecting the second one to be bigger because it has more indexes. 39 against 61. Okay, let's see what was the difference here. Is that the same? 39 and 61. So 29 and 71. You know, for this one, I would actually expect this one to be, I would say, even better, but it's not because this one is based on the include. So maybe that has some overhead. Well, we don't care about that right now, but this one here performed better for the third column. Well, yeah, that's interesting. Okay, well, let's go to the next one. Let's go to delete. Okay, and how many I have here for delete? Delete, I have. Okay, 1, 2, 2, 3. Right. So we're gonna do a delete in for the first column. Okay, we'll see how indexes help them delete. Parse it. I'm already expecting this 3, 4, 4, 9. For the second one, is only 3, 3, and 3. So let's get that. 3, 4, 4, 9, 3, 3, and 3. Okay. Why is that? By now you should probably know, right? This is a table scan. This one is in the clustered index, and the filter is based on the clustered index itself, right? So it will do great. And we see 0%, then we see 1% and 1%, right? If we try to see the difference between those two here, we'll see. Whoa, hold on, what did I do wrong? I don't know what I did wrong. Let's try to run it again. Okay, we'll see that the first one takes less resources than the second one. Why again? Well, the second one has more indexes. Okay, let's go for this one with the second column, right? Try to think what you're going to expect on this, right? There's no indexes on the second column, right? So what do you think it's going to happen? Let's check it. Oh, no, let me come here. Let me go to the parser, parse. And we see 3449, 4857, 4864, and 4420. So it's just the 3449, 4857, then 4864. And as I hope you probably can see and understand that now, it's just doing a full scan, right? That means I'm not using any index. If I go to the execution plan, the first one is going to be better than everyone else. Why? Because it's just the table scan. There's no indexes here in any of those. But what if I do on the third column? Third column has an index on table 3 and 4. Is that going to help? Copy this. Bring to that. And we have 3449, 4857, 3, and 3. So we can see that there was some improvement there, right? 3, 4, 4, 9, 4, 8, 5, 7, 3, and 3. So an index is probably helping on the delete when compared to a heap table or a clustered index, a clustered table without a non-clustered index in the filter, right? You can see that 42, 57%, 0 and 0 and 1. So we actually can see a little bit difference here, but that could be even more. um, you can see that even more if you run only those two, because now you're gonna see a 35 against a 65. So this one has more indexes, right? And look, as I add more index, that's why I have this other one here. Let me add another index here, and that's going to be this one now. And again, is this another redundant uh, index? But I just wanted to see that. Before we had what was that? I think it was 37. 37 against 29. Can't even remember anymore. Oh my head. Well, anyway, it's going to be different now. It's going to be 30 and 70. Let me just delete that again because I can remember. Let me do a okay, let me do a delete. Oh, I have to put an index. What am I doing wrong here? Delete, man. Drop index. All right, so I did that. Now, if I check it again, let's see. And that would also happen in the inserts and updates, okay? I just left that for last so you can see. So here we have 35 and 65. So if I create now the index, we'll see that it's gonna perform even worse the second one, right? So created the index, and then if I come here, now it's 30 against 70, right? And the more I create, the worse this is gonna get. So an index will help a lot if you're using a filtering, if you're using a filter on the appropriate index, be clustered or non-clustered, but it will not help if you have a bunch of indexes there, because now it has to maintain all of those. Okay, so if you can understand this portion, I mean, there's so much more to talk about indexes, right? There's a whole lot. There's like, another hours and hours that we can talk about indexes. But this is the main thing where we see, and I see developers making mistakes, right? Because that's when they kind of like, they think they have to create a bunch of indexes when they shouldn't. Because when they create a bunch of indexes, things are not going to work, or they put a function on an index, or they put a like on an index not in appropriate proper way, or they don't create a covering index, right? Every time you run a query, you should probably use this execution plan and look for the seek, and of course, make some comparisons and see if you really need all those indexes there. Okay, because the indexes can be great, but they will hurt if not used properly. All right, well, check out the other video on the architecture of SQL Server. For databases, the architecture, they're very similar. Of course, some of them are more sophisticated, like Oracle or Postgres has something different. But the main idea is it's kind of the same. Okay, it's kind of the same. And the index is also for all the database, at least for the main ones, Oracle, SQL Server, Postgres, I would say MySQL as well. They work in a very similar way. And I'm talking about row indexes. Okay, they work in a very similar way, and if you understand this, regardless what database you work on, you're gonna make improvements in your database based on index tremendously in whatever database. I don't care if it's Oracle, whatever it is, or Postgres. Okay, all right, guys, check the other video and talk to you later.